Today we're discussing compound event. A compound event is an event that includes multiple sub-events, either together or one at a time. There's two different ways to find the total number of possible outcomes of compound events, but first we're going to just define what a compound event might look like. The example we're going to use imagines that you go to a restaurant where you're allowed to choose a meal. So choosing a meal is the main event. However, within that main event, there's two sub-events. Okay, so the first sub-event is choosing a main dish, beef or chicken. The second sub-event is the side where you can have peas, beans, or grapes. You can see here that there's going to be a larger amount of outcomes. So let's say that we didn't have the side dish. Let's say we only had a main dish. That would mean we have two main outcomes, beef or chicken. However, now we have a sub-event of choosing a side meal. And that means you're going to have multiple combinations of outcomes because the main dish, you choose that first and then you have another option. So you could say, I want beef and peas, or I want beef and beans, or I want beef and grapes, which is a really strange combination, but you could. Or you could choose chicken as your main dish, and now you could have chicken and peas, chicken and beans, or chicken and grapes. So the amount of outcomes actually goes from 2 to 6 because there's now 6 different combinations. There's two different ways of finding the total amount of possible outcomes of possible events. Here's what's called a tree diagram. Here you see the main event is that I'm at a restaurant choosing a meal. My first choice has 2 outcomes, beef or chicken. That's my main dish. Over here I have my side dishes and I've listed them twice. So now you see that stemming off from beef, I have an option to pick one of 3 sides. In either case, either I have beef or any of these, or I have chicken and I have any of these. These outcomes, so the outcomes are listed at the end of the tree. The first outcome is that I have beef and peas. The second outcome I would fill in with beef and beans, etc., etc., etc. Okay, let's say that my example is that I flipped 3 coins. When I make my tree diagram, I see that my main event is just I'm flipping coins. On my first flip, I can get heads or tails. On my second flip, I could also get heads or tails. And I continue to diverge, showing the outcomes for each flip. So this is flip 1, this is flip 2, and this is flip 3. Everything in purple shows me each combination of flips that I could possibly make. So here I follow the chain. I could flip a heads, or a heads, giving H, H, H. On this branch, if I were to say, okay, tails, then a heads, I could get T, H, H. The second way to find all outcomes of compound events is called the fundamental counting principle, and it's actually just like the tree diagrams, except a little bit faster. What it says is that the outcomes of a compound event, so choosing a meal with a main dish then a side, or flipping 3 coins in a row, all you have to do to find the total number of outcomes is to multiply all outcomes of each individual event inside the compound event. Let's go back to our restaurant example. So the faster way to do this without making a tree diagram is to say, okay, in this first part of our compound event, we have 2 possible outcomes. In the second part of our compound event, we had 3 possible outcomes. To find the total amount of possible outcomes for the compound event, we multiply 2 times 3 and get 6 total outcomes, which if we look back and see from our original tree diagram, there are 6 total outcomes listed. If we go back to our coin example, we remember that our first flip has the option of heads or tails, the second flip heads or tails, third flip heads or tails. Well, for the first part of the compound event, there are 2 outcomes. For the second part, there are also 2 outcomes, and for the third part, 2 outcomes again. To find the total amount of possible outcomes for the whole compound event, we simply multiply 2 times 2 times 2 and get 8 possible outcomes, which if we check that with our tree diagram, matches up perfectly.